This lesson follows on from the previous lesson on measures of dispersion, but it is only for the higher tier. If you are studying for the foundation level, then just skip this lesson and move on to the next. In this lesson, we will cover two more measures of dispersion, the interpercentile range and the interdecile range. You should remember this diagram summarising the measures of spread from the previous lesson when we looked at the range, quartiles, interquartile range and percentiles. The three measures in red on the right of the diagram, the interpercentile range, interdecile range and the standard deviation, are only included in the higher tier. This lesson focuses on the interpercentile range and interdecile range. Let's look at the interpercentile range first. You should remember percentiles from the previous lesson. Please make sure you have covered this before continuing with this lesson. We saw that percentiles are the parts when a set of data is divided into 100 equal parts, and that percentiles are used to analyse data. We also worked through an example on how to estimate particular percentiles. The interpercentile range is simply the difference between two percentiles. Let's work through an example. The number of runs made by members of a cricket club are summarised in the table below, and we have a frequency table showing the number of runs in groups and the frequency for each group. We are asked to estimate the 30th and 80th interpercentile range. So the steps we need to go through to answer this question is firstly to estimate the 30th percentile, then estimate the 80th percentile, and finally calculate the difference between the 30th and 80th percentiles, which will be the interpercentile range. Firstly then, we need to estimate the 30th percentile. Now, this is exactly the same as we worked through in the previous lesson, so you might like to pause the video and have a go at yourself before I go through it. So a quick run through of how to calculate the 30th percentile. Remember that the worked example in the previous lesson walks through the calculations a little more slowly, so you may find it helpful to revisit that if you are struggling. The total frequency is 150, which we multiply by 30% to find that the 30th percentile is the 45th value. Using the cumulative frequencies that we've calculated, we can see that the group 21 to 40 has the 24th to the 88th values. So, percentile 30 is in the 21 to 40 class. We can also see from the frequencies that there are 23 values below the 21 to 40 class. So the 45th position of the 30th percentile minus the 23 values in the preceding groups means the 30th percentile is the 22nd value in the 21 to 40 class. From the frequencies, we can see there are 65 values in the class interval of 21 to 40, and the class width for this class is 19, calculated as 40 minus 21. 22 then divided by the 65 multiplied by the class width of 19 equals 6.43. The lower limit of the class 21 to 40 is 21. So if we add these together, it means the 30th percentile is estimated to be 27.43. Returning to the steps we need to carry out to calculate the interpercentile range, we have completed step 1 by estimating the 30th percentile. For step 2, we need to estimate the 80th percentile. Pause the video and have a go at calculating the estimate for the 80th percentile yourself. Here is a summary of the steps that you hopefully worked through to calculate an estimate of the 80th percentile as being 55.83. Remember that you can find the percentiles by using a cumulative frequency chart as well, like we did for quartiles in the previous lesson. We'll come back to this in an example later in this lesson. Again, returning to the steps we need to carry out to calculate the interpercentile range, we have now completed step 2 by estimating the 80th percentile. The final step is to find the difference between the 30th and 80th percentiles, which will give us the interpercentile range. We mentioned earlier that the interpercentile range is the difference between two percentiles, and we can therefore calculate it as the larger percentile minus the smaller percentile. So taking the 80th percentile of 55.83 minus the 30th percentile of 27.43 equals 28.4. So the 30th to 80th interpercentile range is 28.4. Now let's move on to deciles and the interdecile range. We know that percentiles are the parts when a set of data is divided into 100 equal parts. Well, as the name suggests, deciles are the parts when a set of data is divided into 10 equal parts. We write deciles in the same format as for percentiles. So the 9th decile would be written as uppercase D, subscript 9. And the 2nd decile would be written uppercase D, subscript 2. It might be worth just clarifying how percentiles and deciles relate to each other. This may be obvious as percentiles are 100 parts and deciles are 10 parts. So the 20th percentile is equivalent to the 2nd decile. The 50th percentile is equivalent to the 5th decile. And the 90th percentile would be equivalent to the 9th decile. What this also means, of course, is that you are already able to calculate deciles from your knowledge of how to calculate percentiles. We'll do an example anyway, but this time we'll find the interdecile range using a cumulative frequency diagram. Similar to the interpercentile range, the interdecile range is the difference between two deciles. The number of points scored by 100 basketball players during a competition are summarised in the table below. We then have a table with groups for number of points scored and their frequencies. We are asked to estimate the 1st to 8th interdecile range. The first thing we would do is work out the cumulative frequencies for each group. The simplest way is to add an extra column. Pause the video while you calculate the cumulative frequencies. Now we have the cumulative frequencies, we can then use this data to draw a cumulative frequency chart. Here we have the cumulative frequency chart for this data set. If you are unsure of how to draw a cumulative frequency chart, then please revisit the earlier lesson titled Cumulative Frequency Charts back in Unit 2. You could come across a question where they provide a cumulative frequency chart and you just need to use it. Now, our example question asked us to estimate the 1st and 8th interdecile range. So we first need to estimate the 1st and 8th deciles from this chart. To do this, it's the same as we saw in the previous lesson for finding the quartiles on a cumulative frequency chart. The first decile is equivalent to 10%. So we find 10 on the cumulative frequency vertical y-axis, then draw a line across until we meet the cumulative curve. Then draw a vertical line down until we reach the horizontal x-axis. And we read the value off at this point, which in this example is 14. Then we need to do the same for the 8th decile, which is equivalent to 80%. So we find 80 on the cumulative frequency y-axis, draw a line horizontally across until we reach the cumulative curve, then draw vertically down to reach the x-axis and read off the value, which in this example is 54. We know that the interdecile range is the difference between two deciles, so we can calculate the interdecile range as the larger decile minus the smaller decile. We have the first decile as 14 and the 8th decile as 54. So the first 8th interdecile range is 54 minus 14, so it's estimated to be 40. In terms of what you need to know, you need to be able to calculate deciles, calculate the interpercentile range and interdecile range, as well as use interpercentile range or interdecile range to compare data samples and to compare sample data with population data. We will come back and look at comparisons in more detail later in the course. And that's it for interpercentile and interdecile ranges. Now have a go at the questions in the quiz that follows this lesson.